Yes, good morning. Fine. There is test on this Sunday, right? There is test on this Sunday. Which type test? CET or NEET? Sorry, CET or ZEE? Which type? CET. Okay. Syllabus. Write down. Test syllabus. Test syllabus will be chapter magnetic effect of electric current, means current chapter. You can call it as moving charges and magnetism. In our module, they have called it moving charges and magnetism. Okay. Moving charges and magnetism. Okay. Sunday test. Moving charges and magnetism. Moving charges and magnetism. The content that has been taught till today. Okay, the content that has been taught till today. Yesterday we have covered the point of motion of charge particle in magnetic field. That part will also be for the test. And all the MCQs based on the content taught till today, you will solve. Okay. I have already given you the homework of module as well as homework of boards. Okay. बोर्डचा होमवर्क आहे तुमचा ऑसिलेशन चॅप्टर complete reading of its notes and revising that oscillations chapter. Okay. Check all the solved examples taught till today. Check all the MCQs of exercise 1, exercise 2 and the exercise 4 EYQs. Those will be for the exam. Okay. On this Friday and Saturday, offline session of physics will be there, 2 to 5, 2 to 5. Okay. All right. Yesterday we solved example number 20, right? Now let us solve the further examples. Let's see how the further examples can be solved now. Question number 21. Question number 21. Write down. What is given in the question number 21? Write down along with me. An alpha particle travels at an angle 30 degree to the magnetic field. So angle between velocity and magnetic field. Theta is angle between velocity and magnetic field. Angle between velocity and magnetic field. An alpha particle travels at an angle of 30 degree to the magnetic field. So this angle theta is angle. This is the symbol of angle. Angle between velocity and magnetic field is 30 degree. An alpha particle travels at an angle of 30 degree to the magnetic field of 0.8 Tesla. Magnetic field is equal to 0.8 Tesla. Capital T. T is the unit of, Tesla is the unit of magnetic field. With a velocity of 10 raised to 5 meter per second. With a velocity of 10 raised to 5 meter per second. It's an alpha particle. It's an alpha particle. It is helium nucleus. Alpha particle means helium nucleus. Helium nucleus means 2 protons, 2 neutrons. 2 protons, 2 neutrons. 2 protons, 2 neutrons. You should remember this. The magnitude of force will be Magnitude of force, magnetic force acting on the alpha particle. Find out the answer. You know what is the formula for vector form and what is the formula for magnitude of the force. Tell me what is the answer fast. Direct application. Some examples from the exam will be direct application. Do not do any kind of silly mistake in such questions and tell me the answer. Answer sanga, patkan sanga. What is the formula? Force acting on moving charge in magnetic field. Calculate the answer and tell me the final answer. I want final number as answer. You know the formula. Solve it. Do it fast. Kyle? Anyone? Got it? Angle of velocity with the magnetic field given. Alpha particle. Charge, you have to find out. You have to find out charge on it. What is the formula for magnitude of force? So it is Q V B sin theta. Q V B sin theta. You are asked only magnitude, so just put the numbers. Forget about positive, negative. Just put the numbers. You are asked the magnitude of the force. Charge on alpha particle. 2 protons and 2 neutrons. 2 protons have charge 2 times E. 2 protons have charge 2 times E. E means 1.6 into 10 raised to minus 19. Velocity V is already given to you. Keep it as it is. Magnetic field B given to you. Keep it as it is. Sin of theta. Theta is given as 30 degree. Theta is given as 30 degree. Sin 30 you should remember. Okay. Sin 30, sin 60. That table entire you should be remembering that table. 2 times, see now put the values, 2 times 1.6 into 10 raised to minus 19, velocity is 10 raised to 5. Whenever you do the substitution, put the brackets so that you can know that you have substituted what? E substitution, V substitution, magnetic field B is equal to 0.8 Tesla, sin 30 is 1/2. Tell me what is the final answer fast. 2 cancel. 1.6 into 0.8. What is that? 1.6 into 0.8. 1.6 into 0.8. 1.28. 1.28. Okay. No problem. Minus 19 plus 5. Minus 19 plus 5. Minus 19 plus 5. Minus 14. These many Newton. These many Newton. That's it. Dot should be generally arranged after first digit. पहिल्या digit नंतर dot arrange करायचा असतो. That's it. Question over. Okay. Next. Yes, this option is present in the. This answer is present in the options. Number 22. Question number 22. Question number 22. Question number 22. Just try to solve question number 22 now. Baga. Now get familiar with the types of the questions. Okay. Question चा type बरोबर बाळांनो. Familiar व्हा. Second type. Question 22 baga. The particle 1, 2, 3, 4 enter into the magnetic field which is acting upwards as shown in the figure. Acting upwards म्हणण्यापेक्षा going inside म्हणायला पाहिजे होतं. Okay. In this region the magnetic field is going inside. Cross, 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 cross. Magnetic field is going inside. The first particle moves like this, okay. The second particle goes undeviated. The second particle goes undeviated, okay. Third particle goes like this. Fourth particle goes like this. Identify the particles means whether it is a positively charged particle or negatively charged particle. Identify the particles means identify charge on the particle. Who is neutral? Who is positive? Who is negative? That you have to identify. Write down. Identify the particles. Identify the particles. Identify the particles means charge on them. Positive ki negative. Here we are going to make a chart of answer. Answer कसे येणार बघा. Particle and charge. First particle वरचा charge, second वरचा charge, third वरचा charge, fourth वरचा charge. Motion they have indicated by the arrow. Motion has been indicated by the arrow. Okay. You have to use Fleming's left hand rule. Everyone do this. Pointing finger towards the camera, middle finger like this, perpendicular to the first finger, and thumb stretched upwards. First of all do this. First of all do this. See how it is done. Okay. Now magnetic field, you have to show magnetic field inside. First of all, show the magnetic field which is going inside. For the first particle, we will do the analysis. Everyone. For the first particle, motion of the first particle is like this. Motion of the first particle is like this. Forget about the motion. First of all, show the direction of magnetic field. Show the direction of magnetic field inside. For the first particle, direction of magnetic field is inside. The particle curves upward. Particle moves upwards. So the magnetic force should be upwards. Magnetic force should be upwards. Now you people tell me, the middle finger and the motion both are in same direction. The middle finger and the velocity both are in same direction. This thumb is upward means the particle will move upward or it will curve upward. Particle will curve upward. Magnetic field is going inside. First finger going inside, magnetic field going inside. It is moving upward, so thumb should be upward, or the particle is curved upward, so thumb should be upward like this. Now the middle finger and the velocity, that is motion, both are in same direction. It means current and velocity both are in same direction. Means charge is positive or negative. Middle finger means current, but current and velocity both are in same direction. So what does that mean? It is positive or negative? Reply me in the chat box. Everyone, current and velocity found to be in same direction. मग तो charge positive असणार की negative? Show the magnetic field by the first finger. It is moving, it is getting curved upward, so force should be upward like this. The force will change its direction. It will be always towards the center of the circle. Now this middle finger and the motion both are in same direction. This middle finger and the motion both are in same direction. What does that mean? Current due to this motion is same as that of the direction of velocity. Current ची direction आणि velocity ची direction same आहे. म्हणजे तो positive charge आहे. It is a positive charge. Is this clear to all of you? Reply me in the chat box, everyone. Current and velocity both are in same direction. म्हणजे positive charge right ला move होता ना, right ला current तयार होणार. So first charge must be of positive nature. Now tell me second charge. What about second charge? Second charge is not deflecting. Second charge is not deflecting. Sir, it is moving, so it has velocity. Velocity तर आहे त्याला. It is not at rest. So it is not a particle or a charged particle at a rest. It's not a charged particle at rest. It is not deviated. Its direction is not changing. Magnetic force cannot change magnitude. It can change only direction. But even the direction of this charged particle is not changing. So what is the charge on this particle? Direction change होतच नाहीये. Tell me. Correct, Aditya? Everyone? Hmm? Hmm? Tell me. Particle is undeviated. Particle goes undeviated, so its direction not changed. But magnetic force can change only direction, and even that direction is not changed. It means magnetic force is zero. So if this magnetic force is zero, velocity is non-zero. It is moving, so velocity is non-zero. Some magnetic field has been shown. Some magnetic field has been shown. So that is also not zero. Theta, angle between velocity and magnetic field. Velocity is in the plane of the board. Velocity is in the plane of the board, and magnetic field is going inside the board. Velocity is in the plane of the board. Magnetic field cross. Magnetic field is going inside the board. Magnetic field is going inside the board. Velocity is in the plane of the board. So angle between them is 90. Angle between them is 90. So this charge must be zero, because only then you can get the answer as zero. So it must be a neutral particle. Sin 90 is plus 1. Sin 90 is plus 1. So its charge must be zero, only then you can get zero force. And zero force means direction will not be changed, because magnetic force can change only direction. And the direction is change नाही झाली, याचा अर्थ it is a neutral particle. It is a neutral particle. It's a neutral particle. Try to understand. Tell me about third particle. Force. Force असा असला पाहिजे बघा. This should be the direction of force. At each and every point, force should be like this. So tell me, whether velocity and middle finger are in same direction or in opposite direction. Magnetic field going inside दाखवा. Left hand वापरायचा आहे. Fleming's left hand rule. Show the force like this. At each and every point, force should be like this, because this force is changing the direction and bending the particle downwards. Magnetic field going inside. In this entire region, magnetic field is going inside. So first finger should go inside. First finger जी काय आहे? First finger जी काय आहे? First finger should go inside. For the third particle, first finger going inside. This first finger is going inside. Okay. Thumb should be directing the direction of force. Now keeping the first finger pointing inside, rotate your hand. Rotate your hand and check. Now keep the first finger pointing inside. Keep pointing inside as पाहिजे. Keep the first finger pointing inside and rotate your hand in such a way that the thumb points the direction of force. Rotate your hand like this. Now thumb is pointing downwards. Now the middle finger and the motion, that is velocity and the middle finger, are not in same direction. Can you imagine it? Can you imagine it? Everyone will reply me for this point. Middle finger and velocity are in opposite direction. Do this. You also do that. Same करून बघा. Everyone reply me in the chat box. Are you able to check whether the middle finger and velocity both are in same direction or not? Motion is like this, but the middle finger is opposite to the motion. Middle finger at all the points is opposite to the motion. Everyone reply me, is this clear? So this is the motion of the particle, but because of that motion the current is backwards. Backward current means what? Forward motion and backwards current. Motion is forwards, motion is forward, thumb is downward, so it is bending the particle downwards, but middle finger is opposite to the velocity. Middle finger means current, motion forward, current backwards. It means it is a negative charge. It means it is a negative charge. Current is the direction of positive charge, but current is backwards and negative charge is moving forward. Means negative charge is moving forward, and because of that current will be backwards. Current will be backwards. So middle finger and velocity are opposite. Middle finger and velocity are opposite. So charge number 3 is a negative charge. Now tell me, everyone will tell me the answer of fourth. Thumb should point downward. Make sure that your thumb points downward. Magnetic field going inside. First finger inside पाहिजे. Okay, Siddhi, we'll check whether you are right or wrong. Aditya, Aditi, Anuja, everyone, सगळ्यांनी करा बाळांनो. Fleming's left hand rule. फक्त हात बेंड करताना तोडायचा नाही एवढं लक्षात घ्या. अशा पद्धतीने फिरवा की तो खरोखर फिरेल. नाहीतर सरांनी सांगितले हात फिरवायला, keeping the first finger inside, rotate your hand. किती वेळ रोटेट करायचंय ते बघा. मे बी दुसऱ्या साइडनं इझिली एकदा क्लॉकवाईज करून बघा. क्लॉकवाईज नाही होत आहे तर अँटी क्लॉकवाईज करा. डिसाइड करा बाळांनो. फर्स्ट फिंगर पहिल्यांदा हे करायला शिकायचं आहे. पहिल्यांदा फर्स्ट फिंगर लाईक दिस, थंब लाईक दिस, middle finger like this, all three mutually perpendicular to each other. Let's do that. आता तुमच्याकडनं बघायला. ओके, तुमच्याकडनं बघतोय. ओके, so this first finger going inside, okay, but sir thumb should point downwards. So thumb pointing downward. So middle finger and velocity both are in same direction. Motion and middle finger both are in same direction. Middle finger means current. Current is in the direction of velocity. Current is in the direction of motion. If current is in the direction of motion, what does that mean? It is a positive charge. Positive charge ची direction म्हणजेच current ची direction. So it is going to be a positive charge. Are you able to imagine this middle finger and the motion both are in same direction? Okay, so it is a positive charge. Reply in the chat box CW so that we can move on to next question. Question number 23. This is the type of question you can expect. Such kind of questions in the exam and you need to tackle them. टाइप समजून घ्या. मेजर सगळी थेअरी झाली या चॅप्टरची आपली. आता फक्त काही क्वेश्चन्स तुम्हाला सॉल्व्ह करून दाखवणार आहे मी. Many questions I will cover and after that chapter over. Next, चला बाळांनो, question number 23. Very good. And if you have doubt you can ask. Okay, question number 23. Let's check. A uniform magnetic field of 30 millitesla. A uniform magnetic field of 30 millitesla. Magnetic field of 30 millitesla. Milli means 10 raised to minus 3. Milli means 10 raised to minus 3. Exists in the positive x direction. Magnetic field ची direction काय? B bar as a vector. Exist in the positive x direction. So magnitude is 30 millitesla. Magnitude is this. Direction is positive x direction into I cap. Positive x means plus I into I cap. Exist in the positive x direction. The particle of charge plus E and mass 1.67. Particle of charge, one particle is given to you. Definitely it's a proton. Particle, it's a proton. They have not said that it is a proton, but they have given its charge. Charge on the particle Q is equal to plus E, which is equal to 1.6 into 10 to the power minus 19 coulomb, and the mass of that charge particle is 1.67 into 10 raised to minus 27. 1.67 आहे बघा. 1.6 आपण लिहिलं ना, 1.67. पुढचा डिजिट पण कळाला. एव्हरीवन अपडेट द यस्टरडे चार्ट. कालचा चार्ट अपडेट करा. मास ऑफ प्रोटॉन 1.6 केलं होतं, 1.67 करा. पुढचा डिजिट 1.67 into 10 raised to minus 27. Everyone update that chart. Mass of proton, mass of neutron 1.67, 1.67. We wrote it 1.6. Make it 1.67. Mass of proton and mass of neutron 1.67. अजून पुढचे डिजिट कुठल्या एका क्वेश्चन मध्ये मिळाले तर ते पण घेऊ. इट इज स्लाइटली डिफरंट. प्रोटॉन आणि न्यूट्रॉनचं स्लाइटली मास डिफरंट आहे, न्यूट्रॉनचं स्लाइटली जास्त आहे, बट वी टेक देम इक्वल. Next, a particle of charge plus E and mass equal to 1.6 into 10 raised to minus 27 kg is projected into the field along the positive y direction. Direction of velocity, direction of projection means direction of velocity. Initially, the direction of velocity was, the particle was projected in positive y direction. Positive y direction means plus j cap. Positive y direction, that is plus j cap, with a speed of 4.8 into 10 raised to 6. Velocity चा magnitude किती दिलाय? Magnitude of velocity mod of v bar, that is equal to speed, which is equal to 4.8 into 10 raised to plus 6 meter per second. So velocity as a vector, velocity as a vector you can write, velocity as a vector you can write, magnitude is 4.8 into 10 raised to 6, direction is positive y direction, the particle is projected in positive y direction into z cap, particle is projected in positive y direction. Number 1, bit number A, find force on the particle. Find the force on the charged particle in magnitude and direction. Find force in magnitude and direction. Force चा magnitude आणि direction दोन्ही पाहिजे. ठीक आहे. In magnitude and direction. Force चा magnitude आणि direction दोन्ही पाहिजे. Bit number B. Find the force if the particle were negatively charged. Find force if charge equal to minus E. तोच particle negatively charged असता तर, plus E च्या ऐवजी minus E असता तर. Find force if charge is minus E. Direction magnitude दोन्ही काढू. No problem. Number 3. Describe the nature of path followed by the particle. Straight line, circle, ellipse, clockwise, anti-clockwise, in which plane it will rotate, all those things. Describe the path of particle. Describe path of particle. Path followed by particle. Describe path followed by particle. Describe path followed by particle. सर्कल आहे, एलिप्स आहे, कुठल्या प्लेन मध्ये आहे, स्ट्रेट लाईन आहे, कुठल्या प्लेन मध्ये आहे, सर्कल आहे तर किती रेडियसचं सर्कल आहे, ऑल दॅट डिस्क्रिप्शन वी हॅव टू गिव्ह. ओके, सोल्युशन. Bit number A. Okay, let us draw XYZ coordinates. This is X, this is Y, and X cross Y is Z. So Z फळ्याच्या बाहेर येणार. Use your right hand to decide X cross Y. X cross Y, thumb is coming out. X cross Y, thumb is coming out. आता coming out दाखवता तर येत नाही. म्हणून लोक असं दाखवतात. This is going to be the Z direction coming out. This oblique line is this dotted line is going in, this line is coming out. So X cross Y coming out, X cross Y coming out. So that is Z. Fine. Magnetic field is along the X axis. Particle is positively charged and moving along Y direction. So what is the direction of force? Force direction R. Velocity and force perpendicular. Force आणि velocity perpendicular असतील तर Fleming's left hand rule वापरता येतो. Otherwise not. If the angle between velocity and magnetic field, if the angle between velocity and magnetic field is 90, motion of the particle आणि magnetic field हे जर perpendicular असतील तरच, पहिलीच केस बघतोय आपण. ओके, डिस्क्रिप्शन ऑफ मोशन मध्ये आपण काय बघतोय? magnetic field and velocity perpendicular to each other. Magnetic field first finger, velocity or the current middle finger. If the motion of the particle is perpendicular to magnetic field, only then Fleming's left hand rule can be applied. Magnetic field is along the positive x-axis and velocity is along the positive y-axis. So magnetic field and velocity are perpendicular. So you can apply the Fleming's left hand rule to decide the direction of current. To decide the direction of current, Fleming's left hand rule gives force. Left force. F मध्ये F. Left मध्ये पण F आहे, force मध्ये पण F आहे, असं लक्षात ठेवलंय. Fine. It is a positively charged particle. It is a positively charged particle. Sorry, not here. Here. It is a positively charged particle. So current will be in the direction of velocity. If the particle is positively charged, current will be in the direction of velocity. Direction of velocity is positive y. So current will be positive y. So middle finger should point upward. Middle finger should point upward. Upward direction. Velocity is in the positive y direction. So middle finger will point upward because particle is positively charged. If the particle is positively charged, then current is in the direction of velocity. Current is in the direction of velocity. Current means middle finger. So now middle finger will point upward. Middle finger will point upward. Now maintaining the upward direction of the current, maintaining the upward direction of the current, you have to show the direction of magnetic field. Magnetic field is along the positive x-axis, along the positive x-axis. So you have to rotate your hand. See, I am maintaining the direction of middle finger and I am rotating the hand so that I can point the direction of magnetic field along positive x-axis. बोला बाळांनो, thumb going in, coming out. Reply in the chat box. In, out, I or O. पटकन reply याला पाहिजे. Middle finger upward, that is direction of velocity because particle is positively charged. Current ची direction म्हणजे velocity ची direction, कारण particle positively charged आहे. Magnetic field is rightwards along the positive x. Thumb going in, coming out. बोला. Thumb going in, coming out. करा लवकर, हात दुखेल माझा आता. पटपट रिप्लाय करा. हा, करेक्ट. इन, आउट. आर यू एबल टू इमॅजिन? स्वतः करून बघायचं आहे. तुम्ही करायचं स्वतः. परीक्षेमध्ये तुम्हीच करणार आहात. थंब इज गोइंग इन. गोइंग इन म्हणजे कुठली डायरेक्शन? मायनस झेड. गोइंग इन म्हणजे मायनस झेड. कमिंग आउट म्हणजे प्लस झेड. सो पहिल्या बीट मध्ये लिहा डायरेक्शन मायनस झेड. मायनस झेड मीन्स मायनस जे कॅप. दिस इज द डायरेक्शन. ओके, पहिल्यांदा डायरेक्शन ठरवा. ओके, फोर्सचा मॅग्निट्यूड ठरवा आता. मॅग्निट्यूड F इज इक्वल टू क्यू व्ही बी साइन थीटा. मॅग्निट्यूड काय असतो? क्यू व्ही बी साइन थीटा. और वेक्टर म्हणजे काय असतो तो? F बार इज इक्वल टू क्यू इंटू ब्रॅकेट व्ही बार क्रॉस बी बार. F बार इज इक्वल टू क्यू इंटू ब्रॅकेट व्ही बार क्रॉस बी बार. हा, क्यू ची व्हॅल्यू प्लस ई. चार्ज किती आहे? प्लस ई. वेलोसिटी इंटू मॅग्नेटिक फील्ड इंटू साइन ऑफ अँगल बिटवीन देम. Velocity is along the positive y and magnetic field is along the positive x. पॉझिटिव्ह y पॉझिटिव्ह x, अँगल बिटवीन देम 90, sin 90 plus 1 पार्ट y लाच पाहिजे. Put the values 1.6 into 10 raised to minus 19. ची व्हॅल्यू सबस्टिट्यूट केली. Now you want to find magnitude. So don't write plus e minus e. I have written, but no worries. You want to find magnitude, so you need number. You have already decided the direction, so forget about plus minus. Okay. Vector form लिहिला असता. If I have written the vector form, now the sense of direction is required, and for that positive negative signs matter. I have written the vector form f bar equal to q into bracket v bar cross b bar. In that case, if charge is positive, put positive. If the charge is negative, put negative, because that negative sign will matter. Because that negative sign will matter. Okay. Okay, sir. Velocity. Put the value 4.8 into 10 raised to 6. Get familiar with these calculations. Okay. या चॅप्टर मधले कॅल्क्युलेशन असेच असणार आहेत. -19 + 6 वेलॉसिटी जनरली 10 to the power 5, 10 to the power 6. मॅग्नेटिक फील्ड जनरली पॉइंट मध्ये असते, आहे का? मिली टेस्ला 0.03 आहे ते. 30 मिली टेस्ला मीन 0.03, और यू कॅन राईट 30 into 10 raised to -3. मॅग्नेटिक फील्ड झाली sin 90 + 1. डू द कॅल्क्युलेशन अँड टेल मी द आन्सर फास्ट. Arrange the decimal point after first digit. पहिल्या डिजिट नंतर डेसिमल पॉइंट अरेंज करा आणि पहिल्यांदा नंबर सांगा काय आला इंटू 10 ची पॉवर काय आली. बोला. Do the calculation. Get familiar with it. I am not going to help you with calculation now. Multiplication करता यायला पाहिजे तुमचं तुम्हाला. 1.6 into 4.8 into 30. आता पहिल्यांदा 4.8 चा पाडा म्हणता येत नाही आपल्याला. We cannot remember the table of 4.8. So multiply the 4.8 by 16 or 1.6. ती मल्टिप्लिकेशन करून घ्या, मग त्याला 30 किंवा 3 मल्टिप्लाय करा. That should be the approach. झालं का बघा? Once done, reply me. Get familiar with the type. These are the fundamental types of the questions. Based on this, any complex question can be solved. Literally, any complex question can be solved. What is the answer? बोला. Fast. Can we not do this multiplication? This 10 to the power. .304. 10 raised to what? Okay, Siddhi saying -16. -16 तर -16. Newton. Force है ना? Newton. Fine. So bit number 1, bit number A, over. Find the force in magnitude and direction. Direction we have found out by Fleming's left hand rule. We use Fleming's left hand rule. केव्हा वापरायचा आहे? When to be used? When velocity and magnetic field are perpendicular to each other. Okay, Alam saying -14. Okay. Fine. We found out the direction using Fleming's. We used Fleming's left hand rule. Left hand rule. For direction, we use Fleming's left hand rule, and that is to be used only if the current and magnetic field are perpendicular. Current and magnetic field means velocity and magnetic field. Positive charge असेल The direction of velocity is direction of current, and if the negative charge is there, then direction of velocity is opposite to current. Okay, Aditya is saying -16. अरे ठरवा -16 -14. Everyone reply. Is it -14 or -16? -14, -16. Aditya is saying -14. Samadhya saying -16. काय करायचं? मी करायचं तुम्हाला? बर. 4.8 into 1.6 10 पेक्षा जास्त होणार. 10 into 30 10 into 30 अराउंड 300 पर्यंतचा आन्सर. 2 डिजिट लेफ्टला घेतले म्हणजे +2 -19 +6 -3 किती येते? +8 -19 -3 -19 -3 किती येते? -22 -22 +8 it is -16. The answer is -16. Okay, answer is -16. What I did is this. मी काय केलं हे सांगतो तुम्हाला. 1.6 into 4.8 याचा आन्सर 10 पेक्षा मोठा येणार. याचा आन्सर मोर दॅन 10. सो इट विल बी x y डॉट z. 10 पेक्षा मोठा आन्सर. या दोघींची मल्टिप्लिकेशन इंटू 30 इंटू 30. जरी आन्सर 10 म्हटलं मी तरी हे 300 म्हणजे 3 डिजिट नंबर मिळणार. आफ्टर दिस मल्टिप्लिकेशन आय विल गेट 3 डिजिट नंबर. सो दॅट विल गिव्ह मी P Q R. 3 डिजिट नंबर म्हणजे इथे डॉट असेल. Then I shifted this dot 2 times. 1 2. So I got decimal point after first digit. मला पहिल्या डिजिट नंतर डेसिमल पॉइंट मिळाला. पॉइंट मुव्हिंग लेफ्ट +1. 2 वेळा लेफ्टला गेला की +2. सो हे +2 -19 हे +2 हे -19 हे +6 आणि हे -3. That I figured out to be equal to -16. So पहिल्या डिजिट नंतर डॉट आला आणि हा 10 raised to +2 -19 +6 -3 मिळून तो -6 आला. तो पहिल्या डिजिट नंतर डॉट आणि ते -16 आलं. मी स्टील सेइंग इट इज -14. Why? बेरीज -14 येते का याची? Am I wrong in subtraction? सबट्रॅक्शन चुकले का माझी? Tell me, what is that? 2 and 6 is +8. This -19 -3. What is that? -2 -22. What is this answer? -22 and +8 -14. Yes, -14. -14. So right here -14. बघा आता कन्फर्म आहे का? Aditi saying 1.6 into 4.8 is less than 10. It is, even if it is less than 10, it is slightly, if it is closer to 10, after multiplying by 30 you will get a 3 digit number. Only the number of digits are going to matter, Aditi. 4.8 and 1.6. Even if it is closer to 10, even if it is closer to 10, after multiplying by 30, even if it is 5 जरी असतं ते multiplication, after multiplying by 30 you will get a 3 digit number. Okay, so I just made random approximations for guessing 10 power. 10 ची power जी काय आहे गेस करायसाठी मी ही मल्टिप्लिकेशन अप्रॉक्सिमेट करत होतो. Instead of saying more than 10, I should have said closer to 10. I should have said closer to 10. But even after this multiplication, I will get a 3 digit number. Okay, fine. So you can use such tricks. Don't do the exact multiplication of this, because this into this you should be able to guess that it is going to be a 3-digit number. If it is a 3-digit number, P, Q, R, then here you have the dot, then point moving left, left, 2 वेळा left ला, point moving left plus 1. So P point QR into 10 raised to 2. हा 10 raised to 2, हा minus 19, हा plus 6 and हा minus 3. That will be minus 14. Okay, in this way decide the power of 10. Next, bit number B, find the force if charge is negative. Bit number B. Now the charge is negative and its velocity is in the positive y direction. Then current will be opposite to velocity. Motion is upward, that we know. Motion is upward, that we know. But current will not be in the direction of motion. Charge is negative now. They are saying charge is negative. So motion you have to show in the negative, motion is in the positive y direction. Motion is in the positive y direction. Show the Fleming's left hand rule. Motion is upwards, that we know, but current upward or downward, charge is negative. Charge is negative. So current will be opposite to velocity. So middle finger will point downward. Instead of positive y, it will point negative y. So middle finger will point downward. Now maintaining the direction of middle finger, show the direction of magnetic field. Show the direction of magnetic field. Maintaining the direction of, now I am showing from your side. Okay, like this. Maintaining the direction of middle finger, show the direction of magnetic field, positive x, positive x. So the thumb is coming out, thumb is coming out. Coming out means z direction. This z is coming out, this z is going in. This z is coming out. So direction of the force will be positive z. In the second case, direction will be positive z. Positive z means plus, I made a mistake, minus z. Minus z means minus k cap, not minus j cap. You should have told me. Minus z म्हणजे minus k cap and plus z म्हणजे plus k cap. Okay, you can use the Fleming's left hand rule. Magnitude will remain same. Magnitude change करायचं कारण नाही. Magnitude will be same. Q, V, B, sin theta. Now just put the numbers. Positive, negative बघायचंच नाहीये. Velocity आणि magnetic field. Velocity is still upwards. Velocity अजून पण upward आहे. Current downward आहे. Current downward आहे. Velocity तर upwardच आहे. आपल्याला काय लिहायचं इथं? Velocity आणि magnetic field मधला angle लिहायचा. We have to write here angle between velocity and magnetic field. Current downward, current upward. That we will decide for the direction of force. Fleming's left hand rule. But here we have to write the angle between velocity and magnetic field. Now here we want to find out the magnitude of force. So put the value of charge as a number. We want the magnitude. So don't bother about sign there. Okay, so the charge is still 1.6 into 10 raised to minus 19. Velocity is still 4.8 into 10 to the power 6. And sin theta. Theta is angle between velocity and magnetic field. Don't bother about current. Whether current is in the direction of velocity, opposite direction of velocity, that is required to decide the force. Force decide करताना current ची direction middle finger नी द्यायची. आता काय magnitude काढायचा आहे force चा. तिकडे direction काढायची होती. Direction च्या वेळी current पाहिजे. मग decide करा की whether the charge is positive or negative. If the charge is positive, current is in the direction of velocity. If the charge is negative, current is opposite to the velocity. All those things are there. But those are not required here. So theta is angle between velocity and magnetic field. Particle is still moving upwards. Particle is still moving upwards. It is negative, so current is downward. Forget about it. Still moving upwards. Magnetic field still rightwards. Magnetic field along positive x, velocity along positive y. Angle between them 90. Again the answer will be same, 2.304 into 10 to the power minus 14 Newton. That's it. 2.304 into 10 to the power minus 14. Next, bit number C. Describe the path followed by the particle. For which particle? Positive or negative? or q equal to plus e वाल्याचा path. Tell me, if velocity and magnetic field are perpendicular, then the path of the particle is what? This is standard question. theory मध्ये बघितले आपण. Tell me, if the velocity and magnetic field both are perpendicular to each other, particle follows which path? Tell me, which path the particle will travel? Correct. If velocity and magnetic field are perpendicular, particle travels a circular path. Okay. Now, let us decide the plane of the circular path. XY plane, YZ plane, XZ plane. Okay. We know in this region, in this entire region, magnetic field is rightwards. Magnetic field is rightwards. In this region, magnetic field is rightwards. Particle projected upwards. Particle projected upwards in the positive y direction. Now the particle is positively charged, so current will be upwards and magnetic field will be rightwards. So show it, current upwards. Use Fleming's left hand rule. Use Fleming's left hand rule. Particle projected upward. Particle projected upward. So current upward because it is positive charge. Current and velocity both are in same direction. Magnetic field rightwards. Thumb pointing inward. Are thumb pointing inward. So particle will bend inward. Thumb is pointing inward. Thumb गेलाय ना? Thumb आत गेलाय. Particle projected upward. Thumb inward. Magnetic field forward. So particle वरती फेकला. Thumb तर inward आहे. Particle will bend inward and again outward. Inward, outward. So what will be the plane of circular motion? Always remember, the plane of circular motion is perpendicular plane to the direction of magnetic field. Particle असा फेकलाय. Particle असा फेकलाय. Upwards. Magnetic field is forward. So forward direction ला perpendicular plane कुठला आहे? त्या plane मध्ये particle circular motion करणार. Which plane is perpendicular to the plane of magnetic field? Tell me. Are you able to imagine? It's all about imagination. Magnetic field is forward. In this direction you have the magnetic field. Rightward direction. Velocity in the upward direction. So in which plane the particle will perform the circular motion? Circular motion कुठल्या plane मध्ये होणार? In a plane perpendicular to magnetic field. Magnetic field forward, current upwards, thumb inward. So it will bend inward. As the particle bends, current also bends. But magnetic field is always forward. बघा एकदा thumb कसा आहे inwards, परत downwards. हे असं फिरणार आहे particle. Like this. Are you able to imagine it? Particle इथनं up जातोय, in जातोय, down येतोय, out येतोय, परत up. So circular motion, it will perform a circular motion like this. Check whether you are able to imagine it or not. The magnetic field is in forward direction. Magnetic field is in forward direction, and the particle will perform the circular motion in a plane perpendicular to forward direction. This is your forward direction x. So what is the plane perpendicular to x direction? X direction la perpendicular plane कौन है? YZ plane. It is YZ plane. So write down. Describe the path followed by the particle. As angle theta. Theta is what? Angle between velocity and magnetic field is equal to 90 degree. Path followed काय असतोय? Path is circular. Path is circular. Plane of circular motion. Plane of circular motion. Plane of circular motion is equal to plane perpendicular to magnetic field. Always remember, plane perpendicular to magnetic field, which is equal to, magnetic field is right now in the x direction. X direction ला perpendicular plane कुठला असेल? YZ plane. So y dash, sorry, YZ dash plane. It is a YZ plane. That is the plane of circular motion. That is the plane of circular motion. And the last thing, the radius of circular path also you have to find out. Let us solve it here. After this, here let us solve it. Radius of circular path. You find out R is equal to mv upon bq formula. Use the formula R is equal to mv upon bq. R is equal to mv upon bq. कुठनं आलं ते R is equal to mv upon bq? Magnetic fields are force. Force of magnetic field provides the centripetal force. Provides the centripetal force. Magnetic field force is qvb sin theta. qvb sin theta, and centripetal force is mv square upon r. This is applicable only if theta is 90, not always. This is what we are doing. This you can write for theta equal to 90, not always. Next, we want to find out velocity or the radius, actually R is equal to. So just keep on writing. Sin 90 is equal to mv square upon r. V square and v cancel. Q into b into sin 90 is plus 1 is equal to m upon r. R on the left hand side. This v square cancel, v राहिलाय ना, v square cancel झालाय, v राहिलाय. R is equal to r left side ला घ्या, mv upon qb. qb right side ला, r left side ला. Sequence, I do not like this sequence, so I make it mv upon bq. So answer is m. Mass of the particle is given 1.67. It's a proton actually. 1.67 into 10 to the power minus 27. Get familiar with the types of the calculation. Okay. Today you are going to do the calculations. Okay. Take the calculation sheet पण familiar व्हा. Make sure that these numbers you are familiar to calculate. Okay. 1.67 असेल, 1.64 असेल, all those things. Velocity 4.8 into 10 to the power 6. 4.8 into 10 to the power 6 divided by. Also one more interesting point that you should note, that velocity of any particle will not exceed speed of light. Speed of light is the maximum limit on the velocity of any particle. कुठल्याही particle ची velocity speed of light एवढी होणार नाहीये. So it is always less. 3 into 10 raised to 8 is the speed of light. 10 raised to 8 है तो 3 into 10 raised to 8. This is just 10 raised to 6. B, magnetic field. B is what? 30 millitesla. So right there 30 milli means 10 raised to minus 3. 30 millitesla. Charge is what? Charge is 1.6 into 10 raised to minus 19. 1.6 into 10 raised to minus 19. Okay, now a little bit of smart work you can do. 1.67 and 1.6 you can cancel. Slightly more than one answer येणार, because numerator is slightly more than denominator. Slightly more than one answer येणार. Keep that in mind. Cancel this and this. Do entire calculation and choose a number which is slightly more than your answer. Because this division you are writing it as 1. 1.67 upon 1.6, you are writing it as 1, but the answer is going to be slightly more than 1, but you assumed it 1. Calculate entire remaining, do the entire remaining calculation, आणि या 1.67 upon 1.6 ला 1 लिहा, पण ह्याचा आन्सर 1 पेक्षा थोडंसं मोठा आहे, त्यामुळे तुमचं जे काही कॅल्क्युलेशन झालंय त्याच्यापेक्षा थोडंसं मोठं आन्सर ऑप्शन मधनं सिलेक्ट करा. इज दिस क्लिअर टू ऑल ऑफ यू? रिप्लाय इन द चॅट बॉक्स. What I said just now, is that clear to all of you? Make sure that you get familiar with the calculations. This chapter is going to be your strong point. तुमच्या strong zone मध्ये गेला पाहिजे हा chapter. They cannot make anything difficult in this chapter except some calculation. But ultimately calculation means addition, subtraction, multiplication, division and nothing else here. So tell me what is the answer. Take this as 1. 1.67, 1.6, take this as 1. So that will become 4.8 into 10 raised to this minus 27, this plus 6, this minus 3 in the numerator, plus 3, minus 19 in the numerator, plus 19. This 1.6 and 1.67 I have cancelled, call it as 1. This 4.8 I wrote as it is, this 30. That's not a big deal. Certainly not a big deal. 10 ने डिवाइड करा 4.8 होणार, सॉरी 0.48 होणार. 10 ने डिवाइड केलं 0.48 and 0.48 ला 3 ने डिवाइड करा. आन्सर विल बी व्हाट? 10 ने डिवाइड केलं 0.48, 0.48 ला 3 ने डिवाइड करा. 0 आला, पॉइंट आला, 3 के 3, 3 संग 0.16 into 10 to the power minus 27 plus 6 minus 21 plus 3 minus 21 plus 3 minus 18 minus 18 plus 19 plus 1. 10 raised to plus 1 and also the dot we want to shift the right word. 10 raised to plus 1 मुळे dot right ला shift होणार. That's it. 1.6. What is that? Meter. Radius, SI unit. Radius काढले ना, distance है ना ultimately. That's the radius of circular path. Reply in the chat box clear and written. CW. याच्यापेक्षा slightly more answers select करा. त्यांचा आन्सर आलाय 1.67. Their answer is 1.67 meter. My answer is 1.6 meter. Should not be a big deal. Done. Good. 24. Question 24. A positively charged particle of charge Q. Charge Q is given to be a positive charge. And the mass M. Particle चा charge दिलाय, mass दिलाय. First accelerated by the potential difference of V volt or accelerated by the voltage of V volt. Charged particle accelerated by the potential difference of V volt or voltage of V volt. Okay, काय गंमत आहे बघा, अशा टाइपचा क्वेश्चन कसं सॉल्व करायचा. Charged particle, get familiar with the type. Charged particle accelerated by voltage म्हणा, potential difference म्हणा, किती व्होल्टचं? V व्होल्ट. आता हा V कॅपिटल V आणि वेलॉसिटीचा V स्मॉल v. वेलॉसिटीचा V स्मॉल v. The positively charged particle of charge Q and mass M first accelerated by the voltage V. Okay, तो accelerate केला गेला म्हणजे इनिशियली त्याची वेलॉसिटी 0 होती, ती वाढवली गेली by accelerating the charged particle, and now that particle has some velocity, and now that particle is injected or projected in the magnetic field. A positively charged particle of charge Q and mass M first accelerated by the voltage V, then injected into the uniform magnetic field. Charged particle accelerated by the voltage or the potential difference of V and injected or projected injected in the magnetic field, of course uniform magnetic field, and injected in the magnetic field. Okay, find the radius of the circle traced by it. Injected in the magnetic field, find radius of circle, find radius of circle traced by it. तो particle circular motion करना. How do we know it is making a circular motion? They should have told us its velocity of injection, ज्या स्पीडला तो फेकला गेला, ज्या velocity तो फेकला गेला, or the velocity with which it was projected in the magnetic field, that velocity and magnetic field should be perpendicular to each other. So we will take angle between velocity, angle, this is the symbol of angle, angle between velocity and magnetic field is equal to theta is equal to 90 degree, that we will assume now. Okay, otherwise how it will trace a circle? Circle ज्या अर्थी म्हटले त्यांनी, okay, as they have said circle, it means angle between velocity and magnetic field is 90 degree. Okay, they will not specially inform you, they will assume that you can understand this from this word. Circle आहे म्हणून हा angle 90 degree आहे, हे तुमचं तुम्हाला समजायला पाहिजे असं ते म्हणतात. It's okay. This is velocity small v. Small v symbol वेगळा काढा. Let's write an extra point here. Capital V याला potential difference म्हणा. Small v letters वेगळा काढा. Small v should look different than the capital V. Velocity. I want everyone to follow this convention. Otherwise, definitely you will cancel velocity and voltage. इकडचा v आणि तिकडचा v cancel करणार तुम्ही. तसं नाही पाहिजे मला. I don't want like that. I want voltage v different and velocity v different. I want velocity v small v, it should look different. All the velocity v should look different than the capital V. हे सगळे velocity चे v आहेत. So we cancel them from left side, right side. But now it's not possible. What we want to find out? Radius. Physics चा question कसा solve होतो जे मला पाहिजे. R is equal to mv upon bq. R is equal to mv upon bq. Do I know the mass? Yes, mass given, tick mark. Do I know the magnetic field? They have said injected in the magnetic field. So I will take magnetic field as B. So I know the magnetic field. आपल्याला values नाही दिल्या पाहिजे, आपल्याला एक formulas derive करायचे. We simply have to derive the formula. Okay, fine. Have I given the charge? Yes, charge given. Have I given the velocity of the particle with which it was projected in the magnetic field? No, I am not given the velocity. I am given the potential difference with which the particle is injected. Okay, so next motivation is this velocity. To find out radius, you should replace this velocity, everything else is known. So now we are going to derive the formula in which we find the replacement for velocity. That's the motivation for the next step. And that's how every question of physics you are expected to solve. See what you are asked, write the equation for what you are asked, check what are the things in that you know. काय माहित आहे बघा, काय माहित नाही आहे बघा. The thing that you don't know, find the replacement for that in terms of the things which you know. जे माहित नाही आहे त्याची रिप्लेसमेंट शोधा. कशाच्या टर्म मध्ये? जे तुम्हाला माहित आहे त्याच्या टर्म मध्ये. राइट डाउन. work done in accelerating a charge. Just keep on writing. Work done in accelerating a charge by potential difference. PD means potential difference. Work done in accelerating a charge by potential difference is equal to W is equal to V delta Q. Oh, sorry, not V delta Q, Q delta V, or simply QV. Q is the charge. काही लोक पोटेन्शियल डिफरन्सला डेल्टा V म्हणतात. आता इथं पोटेन्शियल डिफरन्सला नुसतंच V लिहिलंय, so we will use V. Now this is not potential. This is not potential at a given point. It is potential difference between the 2 points. It is potential difference. Q delta V असा फॉर्म्युला आहे. Potential difference into charge. Potential difference into charge असा फॉर्म्युला आहे. So this is potential difference. काही लोक आता डेल्टा व्ही सिम्बॉल वापरतात. आता इथं त्यांनी व्ही वापरलाय, क्वेश्चन मध्येच व्ही आहे. सो वी हॅव टू यूज इट ॲज व्ही. But we know it is potential difference into charge. W equal to VQ म्हणताना potential difference into charge. VQ म्हणा, QV म्हणा. Difference. You want to say QV? No problem. You want to say VQ? No problem. But V is potential difference. Fine. Now this work done, we know all the types of work done are ultimately changing kinetic energy of the system. Okay, this work done is changing kinetic energy of charged particle. हे लक्षात घ्या. जे काय वर्क केलं गेलं, the work done in accelerating a charged particle will give it kinetic energy, will actually change its kinetic energy. So this work done is a change in kinetic energy of charged particle. This is a particular type of question you must understand. Sorry. R is equal to mv upon bq. Tick mark, tick mark, tick mark, question mark, question mark. Fine. So what shall I write next? This VQ is equal to change in kinetic energy. Let us write change in kinetic energy as delta Ke. Okay. Now sir, what was initial velocity is not given. What was initial velocity is not given. Whenever initial velocity not given, take it as 0. If there is no way to find out initial velocity, take it as 0. Fine. Final velocity किती घेणार मग? V. Final velocity V घ्या. Final kinetic energy 1 half mv square minus initial velocity sir not given. There is no way. There is no information in which initial velocity is given. Of course, in that case you will take initial velocity 0. Means initial kinetic energy 0. So in short, I wanted to say that you could have directly written this step, third step. Capital VQ is equal to 1 half small v square. 1 half small mv square. 1 half small m small v square. Initial kinetic energy 0 घेणार. Actually it is change in kinetic energy. Always remember this. This word done is change in kinetic energy. It's not the kinetic energy. You want to find out final velocity after accelerating the charge. Initially charge accelerate केला, त्याच्यामुळे velocity change झाली. Velocity change झाली म्हणजे kinetic energy पण change झाली. So final kinetic energy minus initial kinetic energy is equal to work done. After that you will find out final velocity after acceleration. After acceleration, check what is the final velocity, and with that final velocity the particle will move in the magnetic field. Then the magnetic field will change only direction of velocity. त्यानंतर फक्त direction change होईल. त्यानंतर magnetic field change नाही होणार. पण इनिशियली इलेक्ट्रिक फील्ड लावली होती. पोटेन्शियल डिफरन्स लावले म्हणजे काय? इलेक्ट्रिक फील्ड इज ऑलवेज फ्रॉम हायर पोटेन्शियल टू लोअर पोटेन्शियल. सो इनिशियली इलेक्ट्रिक फील्डचा वापर करून चार्ज वॉज ऍक्सेलरेटेड. इलेक्ट्रिक फील्ड कॅन चेंज द डायरेक्शन as well as velocity of the electric field can change the direction as well as magnitude. इलेक्ट्रिक फील्ड ही डायरेक्शन पण चेंज करू शकते, मॅग्निट्यूड पण चेंज करू शकते वेलॉसिटीचा. आता कशासाठी वापरली इलेक्ट्रिक फील्ड? In this question we use the electric field. Electric field means ultimately potential difference. dV by dr is electric field. So potential difference apply केले. Under that potential difference it means you are applying the electric field to accelerate the charge. इथं तुम्ही चार्ज ची velocity increase केली, चार्जचा तुम्ही स्पीड इन्क्रीज केला म्हणणार आहे. ओके, म्हणजे तुम्ही मॅग्निट्यूड ऑफ वेलॉसिटी चेंज केला. 0 टू सम व्हॅल्यू v. Initially speed 0, finally some speed v. Now forget about electric field. Now your charge has some velocity. Charge फेकायचा आहे ना, हातात धरून तर फेकता येत नाही. You cannot have an electron in your hand. So what you do, you create a beam of electron and you accelerate the beam of electron under the application of electric field or under the application of potential difference. हे electrons accelerate केले जातात. And after once the electrons are accelerated or once the charge particle, proton असेल कुठलाही असेल, alpha particle असेल, once you accelerate them, once they achieve some velocity, now forget about electric field, now they are injected in the magnetic field. Now in the magnetic field they can trace the circle, but now the magnetic field can change only magnitude of the velocity. No, now the magnetic field can change only direction of velocity. एकदा का velocity बदलली इलेक्ट्रिक फील्ड, काही ती velocity मिळाली, आता ही velocity आपण काय करतोय, with this velocity the particle is projected in the magnetic field. Now magnetic field is not able to change the magnitude, it can change only direction of velocity. मग ती direction of velocity change होत राहते आणि particle circular motion करत राहते. Is this clear to all of you? Is this discussion clear to all of you? Everyone shall reply me. This is one of the critical points that we have discussed. व्यवस्थित समजून घ्या काय चाललंय इथं प्रोसेस मध्ये. Why they are doing this? This is a practical example. You cannot hold a charge in your hand and you cannot throw it in the magnetic field. No, you cannot do that. You have to accelerate the charge first, give some velocity to the charge, and then you have to project it in the magnetic field. That's the practical scenario. Everyone now reply me in the chat box. Is this discussion clear to all of you? Fast. Good. Good. Okay, fine. Chalo, next. Now what? We have to replace velocity. Yes sir, we can do that, but no replacement for velocity. Let's do it here. Sir, VQ equal to 1 half mv square. Sir, cancel केला असतं बघा तुम्ही इथला v. But I told you, use different letter for velocity and potential difference. Fine sir, v square is equal to this 2vq on the right hand side, this m on the left hand, sorry, this 2 on the right hand side, not right, left hand side, 2 left ला आला, m पण left ला आला. Velocity किती आली? Under root, taking square root on both the side, 2vq by m करा. Call this as equation 1, call this as equation 2, equation 2 unknown, not a big deal. एक unknown v है, एक unknown v है, एक unknown r है. एका इक्वेशन मध्ये दोन unknown चालत नाही. So find out the value of velocity. Yes sir, we found out. V capital काढा. Put this v in this equation. So write down. That's it. We got the answer. आता maybe exam मध्ये numbers दिलेले असतील, mass दिला असेल, potential difference ची value दिली असेल, 50 volt, charge दिला असेल, mass दिला असेल, and you might be asked the radius after accelerating the charge and after injecting it in magnetic field. पहिल्यांदा charge accelerate करायचा, magnetic field मध्ये project करायचा किंवा inject करायचा. Then what is the value of exact value विचारतील. In that case, all the values will be given to you. So equation 2 in 1, that will give you R is equal to m v upon vq. What is that? V किती आहे? Under root 2 vq by m, under root 2 vq by m. This m square root च्या आत घ्या है m square root च्या आत घ्या, हे 1 by bq as it is. नाही हा q पण आत घ्यावा लागेल. m आणि q square root च्या आत घेतला तर m square upon q square. This m inside square root, this q inside square root. तो m square होणार, q square होणार, 2vq by m as it is. बघा properly rearrangements बघा. These rearrangements exactly, these are the rearrangements you are expected to do in the exam. You can check the PYQs. they always take this m and q inside the square root. किंवा if you check करा फायनल ऑप्शन्स मध्ये जे बाहेर ठेवत नाहीत ते m आणि q आत घेतात. m and m square cancel, m square m cancel, q and q square cancel. So 1 by b as it is under root m राहिलाय, 2 राहिलाय. This v divided by q, that will be 1 by b under root 2 mv. Now don't replace this mv as momentum. Mass into velocity nahi hai te. This v is voltage. This v is potential difference, voltage. Don't replace that. Mass into velocity, momentum वगैरह काही नहीं है ते. Okay? Such kind of silly mistakes are done by the students. Don't do that. Do all the things consciously. That's my answer. Reply me in the chat box, clear and written. What is their answer? Correct. This is the final format of the answer expected in the exam. Tell me, CW first. Good. Next, one more question we'll solve and then we'll stop. Question 25. Do it along with me. एकदा सगळे टाइप कव्हर करा. सिमिलर टाइप्स तुम्ही स्वतः पण करू शकताय. सगळे टाइप जरा फक्त कव्हर होऊ देत. Question 25. All these types will be for the exam, okay? You have 4 days. Question 25. H plus म्हणजे काय? Proton, hydrogenचा ion. H plus is proton. H plus means what? One proton. H plus ion, hydrogenचा ion. H plus means proton. H plus, helium plus. Helium plus. Helium plus. Helium मध्ये काय असते? Helium मध्ये 2 प्रोटॉन, 2 न्यूट्रॉन, 2 इलेक्ट्रॉन. 2 protons, 2 neutrons, 2 electrons. 1 electron removed. 1 electron removed. So He plus. 1 electron remove केला. So it will be 2 protons, 2 neutrons, NEU, NEUTRON. 2 neutrons, 1 electron. 1 electron. 1 electron. He plus. O plus plus. O plus plus. Oxygen. 8 proton, 8 neutron. NEUTRON. 8 neutron. 8 electrons are there, but plus plus. So 2 electrons removed. So only 6 electrons will be there. Only 6 electrons will be there. Okay. Okay. H plus, He plus plus, O plus plus have the same kinetic energy. Let us call this as first particle. Let us call this as second particle. Let us call this as third particle. Kinetic energy of the first particle equals kinetic energy of second equals kinetic energy of third. तिघांची kinetic energy same दिली आहे. Okay. These three are the charged particles. त्यांचा charge माहित असला पाहिजे, mass माहित असलं पाहिजे. You should know their charge, you should know their mass. It is given that these three have same kinetic energy. Their kinetic energy same. That doesn't mean their masses are equal and their speeds are equal. Mass पण equal आहे, speed पण equal आहे का? नाही. Kinetic energy equal आहे. म्हणजे 1/2 mv square चा आन्सर equal आहे. सगळे m आणि सगळे v equal नाही आहेत. Velocities might be different, masses might be different, but 1/2 mv square answer for first charge, second charge, third charge. पहिला charge, दूसरा charge, तीसरा charge. For all of them, kinetic energies are equal. That doesn't mean their velocities are equal. That doesn't mean their masses are equal. No. Why their masses are equal? They can be different. Their velocities can be different, but their kinetic energies are same. Okay. Pass through the region in which there is a uniform magnetic field. All of these three people pass through a region in which there is a magnetic field perpendicular to the field. Pass through a region in which there is a uniform magnetic field perpendicular to their velocity. हे सगळेजण कुठल्या रिजन मधून पास होतात? मॅग्नेटिक फील्डच्या रिजन मधून पास होतात, in which that magnetic field is perpendicular to their velocity. So it is given that V1 perpendicular to magnetic field, पहिल्या पार्टिकलची velocity, V2 is also perpendicular to magnetic field. आता V1, V2, V3 म्हणायची गरज नाही. All of them are passing in the same magnetic field, passing through the same magnetic field. Now this is a velocity symbol, so draw it differently. Velocity चा V separate दिसला पाहिजे मला. Velocity of third particle, that is also perpendicular to magnetic field. This data is given. The masses of H plus, He plus, O plus plus are 1 AMU, 4 AMU, 16 AMU. पहिल्याचं mass of the H plus, it is given as 1 AMU. Meaning of AMU चं meaning आहे atomic mass unit. ठीक है, it is some unit of mass, just like kg is a unit of mass, AMU is also unit of mass. Unit of mass है 1 kg equal to some amount AMU. 1 AMU equal to something 1 AMU म्हणजे some amount equal to kg, some amount in kg. Let me write it like this. 1 AMU is a unit of mass, something, some value, एवढे kg असेल ते. Okay, let me check. They have given it? No. We will find this. Will you search it? And will you inform it on the group? Group वरती inform करा. Anyone? 1 AMU equal to how many kg? It's ultimately unit of mass. 1 atomic mass unit. M2 दुसऱ्या पार्टिकलचं मास किती दिलंय? हेलियम, 2 प्रोटॉन 2 न्यूट्रॉन, so it is 4 AMU, 4 times mass of proton. इलेक्ट्रॉनचं मास negligible. ऑक्सिजन 8 प्रोटॉन 8 न्यूट्रॉन, 6 electron mass negligible, 8 proton 8 neutron, 16 times mass of proton, that is 16 AMU, not AMP, AMU. So masses known. Fine. Question is comment on curvature they have written, right? Comment on amount of deflection of each particle. Amount of deflection of each particle. Amount of deflection of each particle. प्रत्येक पार्टिकलच्या डिफ्लेक्शन वरती कमेंट करायची आहे, म्हणजे प्रत्येक पार्टिकलची रेडियस ऑफ कर्वेचर काढायची. The path will be deflected. Magnetic field will bend the path of the charged particle. The particle will be deflected. For that deflection, you have to find out the radius. Okay. Now write down curvature. Curvature is inversely proportional to radius. Okay. Now this is a small radius. This is a very sharp turn. हा sharp turn आहे हा, कारण radius small आहे. So curvature more. Small radius, more curvature. Small radius म्हणजे more curvature. More curvature म्हणजेच more deflection. More curvature म्हणजेच more deflection. And large radius. This is not a sharp turn. हा काय sharp turn नहीं है. So large radius means less curvature. Curvature कमी है, deflection पण कमी है. Less curvature. Curvature and radius are inversely proportional. Less curvature means less deflection. Less curvature means less deflection. After this, write down and reply in the chat box. Are the things taught in today's lecture clear to all of you? Same question will solve tomorrow. Are the things taught in today's lecture clear to all of you? You gonna reply and then you can leave for the maths lecture and the bio lecture. Fast. Sunday test, syllabus, current chapter, things taught till today. Fast, everyone. Are the things taught in today's lecture? Enjoyed? Good. एकदा टाइप माहित झाले ना, क्वेश्चन्स इझिली सुटतात बाळांनो. गुड. Fast, fast, fast. Reply me fast and leave for maths lecture. Good. Put, sir. Time over. Reply fast. Good. Good. लायचं राहिलं असेल स्क्रीनशॉट घ्या पटकन. चलो बाय. Let me end the lecture at this point. Okay. चलो बाय. चलो. Good. Very good.